Hello and welcome to back to I guess these series of videos on nodal analysis. So in the last few videos we have been doing nodal analysis on this particular circuit, and in the last video we actually got the answers that we were looking for. We actually got that our voltage output, our V out, was equal to minus 11.014 volts. That was the answer we came up with. And we also got the answer for our current I0 in the circuit, which was the current that flowed from top to bottom through that 7 ohm resistor right here. We calculated that that current was equal to minus 1.573 amps. So anyway, what I want to do in this video is I want to simulate this circuit using an online tool called Circuit Lab. And that's essentially how, it's one way that we can check our answer. So if you're interested in learning how to use Circuit Lab, hopefully this will show you how to use it. One of the things that I just kind of realized about it, this is the second video I was making, is that if you don't sign in, it'll like lock you out after a while. So if you perhaps one day make videos of your own, create an account before you do it, because it'll lock you out in the middle of recording your video, which is, well, anyway. So anyway, I'm logged in as myself right now, and you can, I guess create an account username. It's free, but I'm at www.circuitlab.com. It's really just an online circuit simulator. I'm running it in Chrome right now. It seems to be running fine. I'll bet it probably runs fine in other browsers too. I'm going to launch the Circuit Lab editor. So I've launched the editor. And now what I'm going to do is I'm just going to drag and drop all of the different elements that I have in my circuit into my workbench to kind of build the circuit. So the first thing I had was a 7 amp current source that went from top to bottom. Then I had a 9 ohm resistor. This was 9 ohms. Then I had a current source that went from bottom to top, so I'm actually going to right-click on that, and I'm going to flip it vertically, so it goes from bottom to top, and this one actually provided 2 amps of current. Then I had 2 more resistors. I had a 7 ohm resistor and a 5 ohm resistor. And then the last thing I'm going to need is a ground node. Most circuit simulators really don't let you run without a ground node attached. So now I'm also just going to click and drag. I'm going to pretty much wire up my circuit. So I'm going to wire all of the elements together like that. So I've got my ground node all wired together, and now I'm going to wire together my top V out node, my V0 node, and I'm also going to name my V0 node. So I'm going to name this V0, because that's what we named it in our circuit. And really, I'm basically done. So I've got my circuit all completely built, and now I'm going to go over to Run, and in the Run tab, I'm going to do a DC simulation, because all I really care about in this circuit is just DC. I don't have any alternating current or no signal or anything. It's just a DC circuit. So I'm going to do DC simulation. And now I'm going to add an expression that I want to measure. I want to measure V0. It actually has already calculated it for me. And actually, if I hover over this number, right now I only show kind of 2 decimal places of precision, but if I hover over it, I get a ton of precision. And we can actually see when we hover over it that this, let me see if I can get it back. There it is. That this number is actually what we calculated. We got minus 11.014 volts. Let me scan back over here. We got minus 11.014 volts here. And this is, when we have the tooltip, when we get the tooltip back, that is minus 11.014, but with a whole lot more precision here. So that's our voltage. And then we also care about our current. Now, the way that I get my current, one of the limitations of this program is it's kind of ambiguous which direction it's saying that current is flowing. But really, I think it's assumed that current is going to flow left to right and top to bottom. So if I consider the current through this resistor R2 to flow from top to bottom, then that current is going to be minus 1.573 amps. Let me actually see, maybe if, oh, I see. This is how we do it. If I take one end of a resistor, one end of a node of a resistor, if you can see down here in a second when I hover my mouse over, I'm going my mouse over the resistor node. You see how it shows me right here the current value. I hover over that. If I select this node, it's going to give me the current that's flowing from this edge of the resistor to this edge of the resistor. However, if I select this node, and I'm actually going to click on this one too, this is what it's calling, and I can get rid of that voltage. This is what it's calling R2 node B. It's going to give me the current here that's flowing from this edge of the resistor, from the bottom of the resistor, to the top edge of the resistor. So if you select both of them, that the current R2.NA is going to be minus 1 times R2.NB. So anyway, that's how, I just realized that's how this works. And the important thing here, I can actually get rid of R2NB because we care about the current that's flowing from the top, from this A node, to the bottom. And that's what this represents. The current is minus 1.573 amps, and if you remember back from our calculations, that's what we calculated, minus 1.573 amps. So we have used Circuit Lab, which is this online tool that you can start using right now, to check our work, to essentially check to make sure that we've done things correctly. One last thing I just kind of want to say on this. A number of circuits textbooks, you have a whole lot of problems that are kind of in the back of the book, and what a number of circuits textbooks do, and obviously not all of them do this, but what a number of circuits textbooks do is they don't print answers to any of those problems. Really what most of those books do when they do that is they are trying to get students to simulate circuits like this, because it's a really good habit to get into to just really know how to use a circuit simulator well. As you could even see in this video, like I was still learning things about Circuit Lab here. But and Circuit Lab is just one possible tool. If you have access to multisim, maybe I'll make a multisim video in the future. It's a very good idea to learn how to simulate a circuit using multisim again, because multisim is a very powerful tool for getting lots and lots of information about these types of circuits. So anyway, hopefully this was useful for you, and I guess we have verified that the answers that we got over the past few videos when we did nodal analysis on this circuit are actually correct. And also it's important to point out that probably the way that this circuit simulator, probably the way that Circuit Lab is solving this circuit is probably by doing nodal analysis. It probably has some type of implementation of nodal analysis that's kind of running under the hood. So anyway, hopefully you found this useful, and in the next video we're actually going to start doing nodal analysis again. We're going to go back and we're going to do nodal analysis. We're going to analyze a more complicated circuit, a circuit that has more than just two nodes using nodal analysis. So thank you so much for watching, and I will see you in a future video. Thanks. See you soon.